In this tutorial, we are going to solve a problem which employs complex numbers. So in this tutorial, we are going to solve two equations, that is simultaneous equations. I have equation 1, then equation 2. We have to solve for Z1 and Z2. So this is an application of complex numbers in linear equations. Stay tuned as I take you through how to solve this problem. Watch the video to the end, and please subscribe if this is the first time you are visiting this channel. So let's get into it. I have this first equation here, which is 2i multiplying z1 plus I multiplying z2 is equal to 2 plus 5i. That is our first equation. The second equation is 3i cubed multiplying z1 minus 2i squared multiplying z2 all is equal to 9 minus 11i. So we are only applying the rules or the method for simplifying simultaneous equation, but here the numbers involved are complex numbers. So we are going to make use of the complex operator. Hence, the rules for complex numbers will be applied in this sense. So we are going to use the method of elimination, as you know already in linear equation. So using the method of elimination, what we do is we make a term in one equation become equal to a corresponding term in the second equation. Then we either subtract or add the two equations to eliminate that particular term. So in this case, from the equation 2, there is negative 2i squared z squared, and I have I z2. Sorry, here is z2. So if I want to eliminate z2 so that I can find z1, then I need to make the coefficient of z2 here to become the same as the coefficient of what? The 2i squared z2. So how do I make such changes? So in order for me to make this equal to this, I'll multiply what I have here, because here is 2i squared. So if I want to change this one, I'll multiply the whole of the first equation by 2i. So this is what I'm going to write. So multiplying equation 1 by 2i, right? So this is what I'll get. If I multiply 2i by the first term here, I'm going to get 4. So let me do this before I solve it. So I'll multiply my 2i, open bracket 2iz1 plus 2i, open bracket iz2 is equal to 2i multiplying the expression 2 plus 5i. So what do I get? 2i times this. Remember, 2 times 2 is 4. I times I is negative 1. So I'll introduce my negative sign here. Then z1 follows. Plus 2 times this I, I'm going to get. So for this side, I have this. So my I and I will give me negative 1. Then the 2 will come. So I'm going to get negative 2. So 2i times I. But the goal of this multiplication here is to make our equation become, to make this term here become equal to what we have here. For that reason, we are not going to multiply the I and I as negative 1. So we will leave it as 2I squared Z2, right, is equal to, here will give me 4I, I by I is -1, so -10, so like -10, right? And this becomes, let me rewrite it, so -4Z1 plus 2I squared Z2 is equal to 4I minus 10. This becomes our third equation. Once we have the third equation, we can see the coefficient of this term here is negative. So meaning adding equation 2 plus 3, I'll have this term as, I'll have this term here adding up to this term, and I have this term adding up, and it will cancel. So you realize that I'll have this cancelling this whole term, because 2I squared Z2 and here is 2I squared Z2, but they have different signs. So therefore I'll be left with, this is already gone, so I'll be left with 3I cubed Z1 minus 4Z1 is equal to, then at this point I'll add my 9 here to this, so 9 will correspond to the -10, then -11I will correspond to 4I. So if you have -11I plus 4I, you'll be getting -7. So we'll be getting -7I, then -10 plus 9 will give us -1, right? And at this point, we are getting our fourth equation. So we can solve the fourth equation to get the value for our Z1, since the equation has the same variable. So at this point, I'm going to factorize my Z1. But before I factorize, you realize that I cube here, I can simplify it to -I, right? So I'll have -3I_Z1 minus 4Z1 is equal to -7I minus 1. And at this point, Z1 will come out, and I'll have -3I minus 4 is equal to -7I minus 1. Therefore, Z1 is simply equal to -7I minus 1 over -3I minus 4. And at this point, you can clearly see that I need to rationalize what I have here before I'll get the actual value for Z1, -3I minus 4. So I have to multiply both the numerator and the denominator by the conjugate of the denominator, which is always the negative of the imaginary. So in this case, I'll be getting 3I minus 4 over 3I minus 4. So Z1 is simply equal to, I'll multiply what I have for the numerators, then the same for the denominators. Multiplying the numerators, if I multiply 7I by this, what am I getting? I'm going to get 7 times 3 is 21. Then I have I times I will give me -1. But there is already negative here, so it will be positive 21. Then the next thing is, so positive 21. The next thing I'm going to do is to multiply -1 by the 3 itself, and that is going to give me -3I, right? Then I move back to this against this, and that is going to give me, you have -4 by -7I, and that is going to give me positive 28I. Then finally, negative 1 by the 4. Negative 4 will give me positive 4, right? All over. For the denominator, I'll have this by this. And I'm going to get 3 times 3 is 9. I have negative here, making it negative 9. But I times I will give me negative 1, making it positive 9, right? So the next thing is this times this. Then negative 4 by this will give me positive 12i. Then this by this will give me negative 12i. Then negative 4 by negative 4 is positive 16. At this point, 21 plus 4 is 25. Negative 3i plus 28i is plus 25i all over. This cancels this, right? 25. And this is simply equal to 1 plus I. So therefore, Z1 is equal to 1 plus I. Once I have Z1, I can easily find Z2 using any of the equations. So let's go back to our equation and see. So I have Z1, so I'm going to use the first equation, which is 2i Z1. So 2i Z1 plus I Z2 is equal to 2 plus 5i, right? So from this equation, I can find my corresponding Z2, so that 2i will come out. My Z1 is 1 plus I Z2 is equal to 2 plus 5i. At this point, 2i multiplies 1, 2i plus I times I is negative, so plus negative 2 plus IZ2 is equal to 2 plus 5i. Hence, I'm going to get IZ2 on the right side should be equal to, I'll move this thing to this. So I'll have 2 plus 2 here. These 2 will add up to this 4. 2i will subtract from 5i plus 3i. Hence, Z2 is simply equal to 4 plus 3i all over I. Z2 is simply going to give me 4 over I plus 3 over I over I. 4 over I is the same as negative 4i. Then this will give me plus 3. So therefore, Z2 is equal to negative 4i plus 3. Thank you for being with me. Please subscribe, like and share for contents like this.